I don't know what to say. In the immortal words of Britney Spears, oops, I did it again, I guess. I think I said in something along the lines in the last video of I was sort of lamenting the fact that it'd been 8 months since the previous video to that, and I promise I won't be another 8 months before the next one. And I guess technically I didn't break that promise, but it was supposed to be sooner than 8 months, not more than 8 months. So I dread to think how long it's been. It's probably been like a year. But as you can see, things have definitely moved on. So I'm going to try and do my best to speed run through the steps that have been made. It's fairly obvious if you're watching this in sequence. The ship is almost in one piece now. The saucer has been permanently attached. The upper part of the saucer is the next thing to get glued down permanently. This joint has been massively reinforced by obviously a ton of epoxy and some steel enforced epoxy putty there. If you've seen my other videos, you'll know I love this stuff. So it's been employed there to good use, and I probably covered that in a previous video. I don't know, I was probably in my 20s when I made that video. I can't remember. Anyway, so yeah, basically everything is done construction wise to a point where now it all needs to start getting glued together and become as a single thing, so I can take care of all of the seam work. Tell a lie, actually, no. The nacelles are just popped on for the minute. These are going to be handled as sub-assemblies and then painted and everything, because it's easier to get at seam work and stuff and paint work underneath this section when they're not part of the actual ship, like when they're not permanently attached. So that's what I'll do. So my plan of attack will be to fully paint and finish these parts separately as they are. When it comes time, when everything else is painted and it comes time to a final assembly, these will be permanently bonded, the lighting system will be connected, then the lids will get glued into place. I bet you can't see that from there, but that blue glow looks lovely. I'll move the camera in a minute, don't worry. So yeah, I'll put these in place. They'll be fully painted, so it'll just be a case of a little bit of touch-up seam work there, touch-up paint work, glue the facades in place. They'll be fully painted, obviously, and it should be easy enough to tackle it that way with minimal disruption and paint touch-ups needed. So that's what I'll do. Just try and speed run this, because what I want this video to be more than anything is a pretty in-depth look at this magic black box from Andy Casey at Scalectronics. This is his Innerlight system. You've heard me mention it plenty of times in previous videos, and I've known Andy for quite a few years now, and I've got a few of these systems that were planned for use in other commissions that were supposed to take place before now, but because of various reasons this has ended up being the first project where I've actually used one in anger, so to speak. So so apologies to Andy. Full disclosure, I paid for these, or rather like the commission clients paid for these. Andy didn't give me any of this stuff, so this isn't a paid advert. This is just me singing his praises, because this system is really, really, really amazing. But we'll get to that later. So back to the speed run then. So yeah, everything has been trunked and run. You can see all of the lighting system is in. I'll cover the lighting system in more detail, but it's basically, because it's a smart system, it's basically one long unbroken string of smart LEDs from start to finish. Even though they're placed in strategic areas, it is one long unbroken data chain from LED 1, which is inside the belly somewhere, all the way through to the very last LED in the string, which is this facade LED right there. That's the very final one. So now I've got all of that in place and I know the system is working. My tablet's gone to sleep, but if you can see that, you're not going to see it in detail, but this is part of the like the user interface for the lighting system, and I've got all of the different window lights and basically all the light groupings doing different things. They're all sort of submarked into subgroupings in the controller. Again, I'm going to get into this a lot more in depth in a minute. I'm just being my normal scattershot self. So the saucer is the next thing that needs to be glued down permanently. This joint here is going to be a problem. That's life. The nacelles won't be permanently attached, as I've just said. In the last video I was talking about doing the same greebly exposed panel details for the nacelles. They've all been done. So I think what I'll probably do is at the end of this video, to save interruptions, at the end of the video, if I remember, I'll drop in some photos of that work being done and how they look. They've been sort of basically painted similar. You might not be able to see very well from where you are right up in the rafters, but the exposed greebles on the rest of the ship, they've been basically painted just because it's easier to paint those now and mask them off, ready for painting the actual hull colours and everything later. So I decided to do that now, and we're basically good to go for the final big assembly messy work before we get into the making it look good and making it look like a starship instead of a collection of fiberglass parts. So before I move the camera and get into the lighting system, and apologies if I've massively skipped over some details here, but like I said, it's been like a year, but whatever. I just need to get this done. One last interesting thing is, as of last week or two ago, I'm not sure now, Helios Models released their 1000 scale version of their Enterprise D, and I've got one of those to develop the paint masks. And here is why the requests that I always get about, can you do this, can you do me a set of masks at 700 scale or 300 scale or 259.3 scale, you know, those sorts of questions. I get it a lot, and I understand why people would assume that if you've got a mask set and it's for the Enterprise, you can just make it bigger or smaller for my particular 3D printed kit. This is why that doesn't work. These are supposed to be both 1000 scale. They're both the Enterprise D. They're made by completely different people. This is why I can't just say, yeah, I'll scale this down to 700 scale and it will work for your 3D print, because they're just not the same. There are too many differences. Even like the contours and the shapes here, they're all different. I guarantee the phaser strip is in a different place. The windows are in a different place. It just doesn't translate like that. To make a set of masks for any model kit, it needs to be bespoke to that model kit. You can't just scale up an existing one or scale down an existing product and assume it's going to fit a completely different kit. Okay, anyway, rant over. But I just thought that was an interesting size comparison anyway, considering they're supposed to be 1000 scale, both of them. Who knows where the numbers are from. Anyway, back to the actual subject of the video, and that is getting into this lighting system. So I'm a vinyl dinosaur. If I can do this, anyone can do this. I'm the sort of guy that until recently I was thinking of how am I going to demonstrate programming and using this interface on one screen while I'm recording on another. I don't know anything about screen recording, multi-screens and all the rest of it, but I was considering setting up another mobile phone to film me interacting with a screen. This is the kind of tech genius that you're dealing with, right? So if I can do this, you can do it. So what I'm going to do is set up a different setup. I'm going to get a blank controller that has none of the information put on it, and I'm going to show you how quick it is to get all of these lights from a blank brain to doing what we see here using the Innerlight system from scratch. Okay, so it's going to be a really Stone Age walkthrough, because like I said, I'm not a tech genius, but you're going to see how easy it is, because if I can do it, you can do it. and this system is amazing. So let me get reset for that, and we will see how this goes. Right, so here we go then. Like I just said, I am a massive vinyl dinosaur, but I've figured out enough of this screen recording malarkey on this tablet. So my intention will be to try and cut in the more detailed sort of interactions going on the tablet and for the user interface for the Innerlight system, and I'll cut it into this footage, and you'll be able to see as I'm messing around with stuff on the tablet what effect it's having on the lighting system inside the model. So that's the idea. Hopefully I can make sense of all this in the edit. We'll find out, because I've not done it before. So here we go. Every day is a school day. So this is a brand new sort of blank brain. This is the inner lighting system main controller. So we're starting from scratch for all intents and purposes. You're going to see how easy it is to build the controller system software to control the lights that you've got installed in a model. Piece of cake, really easy. So the fundamental thing that you need to know is that this system is basically a computer that Andy has made a program that talks to all of the smart LEDs that run in one long unbroken string. Basically, that is the bottom line. That is as basic as I can sort of describe it. Like I said a few moments ago in the other video, you've got a data chain, which is the green cable, red and black for power, obviously. So you've got the data chain that's going in, it goes to the first LED, and then that data chain goes in sequence to the next one in a big long daisy chain. It snakes its way all the way around the model, up into the nacelles, back down again through the pylon, up into this nacelle, and it's probably off camera, but the very last LED in that long daisy chain is in that Bassard collector there. So there's a little bit of planning work that you need to do in like while you're building your model. You need to sort of plan your routing for how you're going to get from one LED to the next, but it's, you know, nothing too taxing. Should be able to figure that out pretty well. And then the other thing you need to consider and keep notes on, which is what I've done, is as you're creating your daisy chain and as you're building your light system, it's good to keep a list of what LEDs are doing what, or what you want them to do in the string. So I've got a cheat sheet here. I'm not sure if you can see it on screen, but basically I've got my LED numbers and then a description of what those LEDs are doing. So for instance, LEDs 1 to 3, they're in the secondary hull and they're for some of the windows. And then from 4 to 6, that's where they jump and they need to become deflector dish. So they're going to be blue, not white. And then further down, you continue through the string. 7, 8 and 9, they're more secondary hull windows, so there'll be a set of LEDs somewhere else inside there. They're LEDs 7, 8 and 9. And basically you keep track, each time you're adding a section, you just keep track of what you want that section to be, whether it be a bank of windows, a blue string for the nacelle grills. So that's back here, port nacelle grill. Don't know if you can see that. That's 150 to 174. This is the port sides. That's that run of LEDs in there. So this is your fundamental. This is the foundation that you're going to build your lighting system on. Now, normally you would do this and configure the system while you're going, so you don't need to keep track of it. I need to keep track of it in case I need to make changes later. And while the model's all sealed up, I'm not really necessarily going to know what number LEDs do what. There are ways that you can test it in the software, but it's easier if you just keep a note of it whilst you're doing it. It's going to save you time later, and it's going to pay off later as well. It's going to make things easier for you. So I'm going to use this cheat sheet to program this LED controller to get us exactly what we saw before with the old one. So all of that preamble out of the way. So the first thing you do is you connect up your system. You can follow Andy's instructions that are included with it. It's very easy. It runs off a USB, and he provides this little like bracket, 3D printed bracket. This is the only pin that you need to connect to whilst you're configuring stuff. This is your data chain, and it goes into this like cable connection, and then it goes from power and data, which is the green, like I said a few minutes ago. So you get your everything plugged in, and we're going to throw the switch. Now, like I said, this thing is a computer, so you need to think about it and treat it like one. You can't just power it on and off if you have problems. You need to shut it down. Same as a computer. You don't just yank the power, you need to shut the computer down, otherwise you're going to give it problems and cause yourself issues later with corruption and stuff like that. So, this thing will start doing its boot up sequence. If there's no program on it, it won't do anything. So although it's on, there are some LEDs in the back there buried in the casing, so I can see that it's on, but it's not doing anything because I haven't told it to do anything. At the minute, it's got a blank brain. So first thing to do is you go to your Wi-Fi settings. So you come into your settings up here, go to your Wi-Fi, and you should see it. It will start transmitting its own Wi-Fi network. So it will be here under Innerlight. Ignore the rest of these are the neighbours. So you want to connect to the Innerlight Wi-Fi system. The default password is always Innerlight, so I haven't changed any of that. So you just put your default password in, Innerlight, and connect. Give it a few seconds. These will start talking to each other. He says, hopefully. Sometimes it takes a little while. Okay, so we're connecting. It's just checking. It says it's checking the quality of the internet. Obviously, this thing doesn't connect to the internet. They're just connecting to each other. Connected without internet. Good. So we're talking to each other. We've got good signal strength there. So now we come back. So this, like I said, this is all app based. It's all web interface. So for while you're configuring stuff, you go to Chrome. Again, all of this is in the instructions. So this is just me going through it. You're asked to go to this this web address here, 192.168.1.100. So you navigate your way to that, and then you can interface with this is basically, from what I understand, that web address is just so you can see the software inside this. That's how I understand it. So if we go to, and just turn that off. If we go to main, this is where you put like your very basic fundamental level sort of parameters in. Looking back at my cheat sheet, I know that I've got a maximum of 205 LEDs in this entire thing. I think, if I remember rightly, this thing can control up to 1,000 LEDs. So a model this size only needs, for my purposes anyway, 200. So I can run 5 of these from this brain. Not that I'd ever need to, but you can do that, or you can build something that needs so many more LEDs. So for example, if you were configuring this to have a phaser fire effect, you would have a lot more LEDs in there then. But even still, this thing has got plenty of power, plenty of juice that it can cope with all of that stuff. So here we'll see number of LEDs, 225, it doesn't matter. Max brightness, that's a kind of important thing. As you start building more and more complex systems, the power supply can start to struggle. So you need to figure out different ways of adding more power, and you'll start to get some weirdness going on with the LEDs. I had this fairly recently actually. So one of the ways to diagnose that is if you reduce this down to something like 50, for example, it will run the LEDs at much lower brightness, and then if you start to see all of those weird issues start to go away, then you know that it's a power related issue. Chances are it is. Just get rid of that. So got secondary LED chain. I haven't messed with any of that. LEDs to swap red and green. Again, I haven't messed with any of that. Default startup scene all on, shutdown scene all off. This will start to make sense as we get through the system a little bit more. So there's and then there's always a green save like button on any of these things that you're changing. So I'm going to leave my max brightness at 200. The LED type I'm using is 3-channel RGB. You can change that. Different types of smart LED or programmable LED strips. They come with a white diode, which is probably the better system to use. But at the time I just chose RGB. Basically what that means is any LED that I want to be white, it powers each of the 3 channels equally, so you get a white light because it's mixing the red, green and blue LEDs in each chip at the same power, if that makes sense. If I was using a 4-channel, it would be using the white specific part of the LED rather than mixing the RGB. Hope that makes sense. Don't worry if it didn't. So that's your main page. So if you go to LED grouping now, it comes with main folder, sort of preloaded, and you can add subsequent folders for whatever you want to do. I haven't gotten into any of that yet. I haven't needed it. So if we go, just open up the main folder, and then we've got the folder name. We can change that to whatever we want. So we'll go with let's go with Enterprise. Check out my typing. D test, and then we'll save the name. So the folder name has been changed. You can see there, and then in the folder you add LED groups. So this is where you start to build that list of all of your separate LED groupings. Again, Windows would be a group in my case. Deflector would be a group. Any flashing lights, you can configure those into a group. Basically, you can do whatever you want with it. So any type of LED that you want to be considered as the same grouping, that's where you would put it. So in my case, I'm going pretty fine with the way that I'm breaking all this down. So I'll have the port nacelle and the starboard nacelles. More than likely, I'll have those on separate groupings. But anyway, so at the moment, we've only got one LED group in there, and it says all lights. So if we open that up, and if you look in this particular LED grouping, so we've got the group name is all lights, numbered LED components includes the following. So this is also a drop down option. So you got includes the following or includes all except the following. So this is interesting because it's a time saver. Say for example, I've got 1,000 LEDs in this ship, and out of that 1,000, I want all of them to do one thing except for 10, and the 10 are scattered throughout that string. So instead of me putting, I want all of these lights to include the following, and then having to pass out 1 to 500, and then 502 to 800, and then 802, all the rest of it, you can say all LEDs except 1, 10, 15, blah, blah, blah. It's a time-saving thing. I hope that makes sense. Again, I'm probably not doing a very good job of explaining this. Andy, I'm really sorry if I put people off this system. I'm doing my best. Anyway, so in this instance, I just want all LEDs to be all LEDs, right? So from 1 to 225, so that's fine. So for finding LEDs in a particular string, like I said, I've got this cheat sheet. If you didn't have that, you can use this function here, which is identify. And if I press that, everything flashes red because I'm asking it to flash everything. If I add another group, so I've pressed add LED group and it's added a new group. So I open up that new group, and I'm going to call this sec hull windows. Okay. So I've created a new group, and this group is going to be all the secondary hull window LEDs. Now, if I didn't know where they were, and I was just going to have to start counting at random, you can just start putting LED numbers in here, use the identify tool, and it will flash those LEDs, and you should be able to work out whereabouts they are depending on where you're seeing red lights flash. It's not foolproof, but it is a way to do it. I strongly suggest you create yourself a cheat sheet like this. So what I'm going to do now is I'm going to run through this list in real time, and I'm going to input these LED numbers wherever it's a secondary hull window, wherever I've got it marked. I'm going to put those numbers into this data line here. So it includes the following, that's fine. So we've got 1 to 3, comma, 7 to 9, comma. Apologies, this is going to be painful to watch an old fart like me poke at a thing with his middle finger. You're just going to have to get on with it. 7 to 9, 13 to 21, 34 to 42. How many more we got? That's it. That's all of our secondary hull windows. Okay. Save changes. Now, if I press identify, it should only light up the secondary hull in red. And that's what we're seeing. The secondary hull, not the dorsal, the secondary hull. You see that? Okay, cool. So we collapse that group. We're going to create a new group. New group has been created. It always drops them at the bottom. So when you've pressed the button and you don't see it created, just scroll up. It will be there. That caught me out a few times. I was kept pressing. And then when I scrolled up, I'd added about 50 groups. Again, I'm a vinyl dinosaur. If I could do this, you're gonna see that if this is painful for you to watch, it's hopefully illustrating how easy this system is, because I can do it and this isn't easy for me. So, new group. We're going to call this deflector. Deflector includes the following, and in my cheat sheet I've got the deflector lights. They are LEDs 4 to 6. Okay, save changes, and now again I'll press identify, and the LEDs are flashing red for the deflector. So basically that's how you add your LED grouping. So to save you pain, because I know this is painful, I'm going to run through this cheat sheet. I'm going to create all of my subgroups, and then we'll come back. Yeah, how about that? Okay, so I spent about 5 or 10 minutes just creating this set of subgroupings for all of the different areas that I want to be able to control. So obviously you can do whatever you want, but I want to try and maintain close control on as many assemblies as possible. So I've split out the port and nacelle, the port and starboard nacelle grills, for example, whereas you might treat them both the same. You can do whatever you want with this system. You can literally assign something different to every one of those 205 LEDs if you wanted to go that crazy, but we don't need to, obviously. So I've created this list now. Each folder is named so it makes sense to myself. So secondary hull windows, deflector, dorsal windows, you saw me set those up. Saucer windows is a good example of this conventional or this like methodology, the way you input the data. So you've got LEDs 50 to 60 are windows, then 61 is skipped because it's probably a marker light, so I'm asking it to do something other than be a white LED. So then there's a comma there, and you go 62 because that's the next LED in the string that I want to be a white LED for the windows. So 62 to 103, those windows, they're all those LEDs, sorry, are window LEDs. And then 104 again is skipped. Probably it's a marker light or something like that. And you just create your list like that. So again, like beating a dead horse, keeping a note of what LEDs you're intending to use for certain things is key. Particularly when you get into more sort of complicated systems. So keep a note of it. You'll be doing this as you're creating and as you're building up the system anyway. You need to be doing it, but keeping a note of it so you can refer back to it is pretty critical. So there's that. So yeah, so I've created all of my subsets, and then all of like the kind of flashes, I've put these at the bottom just so they're all sort of together. So I've got white solid on markers, white flashes, 10 and 146. So 10 is the bridge. No, sorry, keel is the number 10, and 146 is the bridge flasher, and things like that. So there are all my subsets. So okay, we've told now the brain how many LEDs it's dealing with, and we've broken those LEDs into subsections. Now we're going to create some LED effects. So the next tab over, LED effects, missed it. Next tab over is LED effects. So we've opened that up, and then you go through that same folder creation process. So it starts off with an off, and this is a very useful thing just to leave in there whilst you're testing and creating parts of your system. So if we just open this up, the effect name, again, you can change it to whatever you want. You could put your wife's name, your dog's name, whatever you want, just so it makes sense to you. Then next to that, we've got the effect type. That drop down menu there, I'll come to that in a second. Test LED group. That is the LED group that we want to assign this effect. And then we've got a duration. If we press that, I'll just come off of that. We've got once or repeating. I'll come back to that again. Then we've got our color selection. So if we press the color, it opens up this interaction, or this sort of range of colors. There's a few different ways that you can select and change the colors that you want to use. You can create faded, use the faders to create the sort of custom color that you want, or you can, use a color picker tool, or you've got the checker mark thing here. You just pick a color. Pretty simple stuff. So obviously for off, we're going with black. Black means off. So we'll select black again, and then the fade and transition time for that effect. So let's create a new effect. Let's say Windows on, or actually, no, I'll tell you what we'll do. We'll say white Windows fade or something like that. Windows fade. And we want it to be a solid color. Again, in this drop down, you've got three options: solid color, flashing and chasing. I'll get to the flashing and chasing a bit later. So we want a solid color, and we're going to test this on the secondary hole windows. Why not? No, saucer. Let's go saucer because it's easier to see. Where are they? Missed it. Saucer windows, just there. We want this to be once. We don't want it to be a repeating effect. It's automatically loaded in the white there. It's automatically loaded in it as a white color there just by default, so that's good. And then the fade time. So you can set this to whatever you want. If you put it at 0, the lights will just be at max brightness straight away. Obviously, if you want it to ramp up, you put however many seconds you want it to ramp up. So let's say 3 seconds, why not? And save that. And now we can test that effect by pressing the test effect button. And I think you could make it out. So the LED's lit up. Let me just switch it off again. Hold on a sec. So we can use the off effect just to switch those back off. and then the test effect on the windows fade again. And there we go. Cool. So before we add more effects, I'm just going to show you then how you employ that effect into other areas of the model that you're making. So this is where the scenes function comes in. So the next tab over, that's scenes. So we go to scenes, and the default is all off. So if you can open that up. This is all starting to become very familiar now, I'm sure. The all off is our default, so we're going to leave that. Basically, that's configured to turn every LED off. Again, it's useful tool, so let's just test that scene for now and make sure all the lights are off. Okay, so I'm going to create a new scene. And what a scene is where you're starting, like I say, you're starting to employ the LED groupings that you've created in the first place, and then you're assigning you're assigning effects that you've created to different areas or different groupings of the LED groups, if that makes sense. So I've created a new scene, so we're going to open that up, and I'm going to call this Startup, because everyone loves a spaceship when it starts lighting up in sections, don't they? It seems to be a thing. So we're going to create a startup sequence just for these windows, just real quick. So we've called it startup. Right, input trigger. So I'm not going to get into this because I haven't actually done it yet, but rather than all software based, you can configure this unit to respond to button inputs, like old school tactile buttons, rather than push button on a touch screen, things like that. I'm not going to do any of that because I've never done it and I can't demonstrate it, but you have got that option. Descriptive primary, I never mess around with any of that stuff. So this is the important stuff. This is where the rubber meets the road, so to speak. So we're going to add an LED effect. Now the first thing it asks you to choose is the LED group that you want to apply an effect to. So I'm going to say, let's start in the secondary hull windows, and it applies this effect. So this is where your effect, this is where your LED effects list would be. There's only 2 here at the moment because I've only created 1 and the off was the default. So I'm going to select Windows Fade, and then we can set a delay. So obviously it's at 0, so as soon as the system boots up, it will start that effect immediately. So let's just leave that at 0. So that's fine. We're going to add another effect. So again, all this is starting to become familiar by now, I'm sure, the way that this whole system is built. So we're going to choose the next LED group, and we're going to go dorsal windows and Windows Fade, and we're going to tell the system to wait 3 seconds. So again, we can put anything in there, and these dice, you can press that and it will just put a random one in for you. If you don't want to sit there thinking about, oh, I don't know what it was, or I can't think of anything, you just ask it and it puts a random one in there. So, but I'm going to put 3 seconds, and then once more, saucer lights, saucer windows, Windows Fade, and we're going to ask for 6 seconds delay. So now what should happen is when we test this scene, the secondary hull windows will come straight on. It will wait 3 seconds before the dorsal lights come on, and wait a further 3 seconds for the window lights to come on. So let's see if that worked. There's a secondary hull, dorsal, saucer. If you can see that, let's just do that again. Test effects, switch them all off. I'll just lift the lid. Test the scene. There's the secondary hull, dorsal, and the saucer lights, window lights. So there we go. So I'm hoping that I'm doing a good enough job of explaining how all of this works and just how quickly now we can start to create pretty complicated interactions and effects depending on how complicated and finely grouped we've made the LED groupings, if that makes sense. So I can subset even sections of windows if I wanted to, and I could have this set of windows. As long as I know which LEDs are here, I can ask the system, set this set of windows to go off in 10 minutes, or don't switch on until 3 minutes. Or you can have that really fine or that really complicated startup sequence where you get banks of windows switching on rather than an entire saucer section at the same time. I'm hoping you're starting to see the power of this system, because and there's no programming in here. It's all drop down menus. It's all web interface. It's so simple. It's got even more expansion capabilities, so you can add 3.3 volts, 3.3 volt base controller output, expansion board effects. I don't know anything about that. Like, this is an old version of the firmware. Andy has released a newer version that's got even more functions and more capabilities. So yeah, this inner lighting system, calling it a lighting kit is just so underselling it. This thing is a computer system, and you can do some amazing things with it, even if you're like a total vinyl dinosaur like I am. So I hope that kind of explains some of it. Oh, I'll tell you what I haven't covered actually. We haven't covered flashing light effects. So let's just do that real quickly. Let's just create a new effect. We'll call it, obviously we'll call it a flash. No, spell it right, flasher. And we'll go for, we obviously want the effect to be a flashing effect. So we go from color, solid color, to flashing. The lower interface sort of, the screen parameter changes. We're going to test this on, let's test it just for a laugh, just so we can see it. We're going to test it on the starboard nacelle grill. Obviously you would assign it to a flasher light. I'm just going to do it here so you can see it. Yeah, so number of flashes, pretty self-explanatory. We'll leave it at 1. Flash color, let's just for a laugh, let's pick yellow. Select, so we're going to get it flashing yellow. Flash time 1 second, rest time 1 second. So that's, the flash time is how long they're lit for, and the rest time is how long they wait until they flash again. So we'll leave it at 1 and 1, and we'll test that effect. Of course you can't see it because it's a starboard nacelle. Let's put it on the port nacelle. Where's the port? Port nacelle grill. Test effect. Tell you what, I'll turn it off because the starboard one's still going, so it's a bit confusing. Test effect, flasher. So we've got it flashing on a 1-to-1, like 1 second on, 1 second off. If I want this to be a lot more abrupt, I'll say 0.2 seconds. Save changes, test the effect. So it's a lot quicker, a lot, you know, it's a lot more sort of abrupt flash. I can change the color again, obviously. Let's go to white. Select, save changes, test the effect. Oops, test the effect. So now it's flashing white. Okay, let's have it a chase. Why not? We'll do it repeating rather than once. We'll have that chase keep going over and over and over, and between time cycles we'll leave that at 1 just for now. We'll have it chase backwards because it's a warp engine. Things go backwards, whatever. Let's leave all these where they are just for now, and we'll just see what it does. And there we go. Anyway, let's just switch all that off and get back to the window fade. So I hope this makes sense. It really is a really good system. I can't sing its praises high enough, really. And like I keep saying, being a vinyl dinosaur, for me to be able to get it to do this in such a short amount of time so easily, I know this system has so much more capability than I've even got to grips with yet. So please do yourself a favour, if you've got a complicated project or you want to get into lighting, complicated lighting systems, but you don't want to learn programming and things like that, get this. I know you're thinking, you might look at the price and you think, yeah, that's a lot of money for a lighting kit. It's not a lighting kit. This thing is a computer system that is doing so much stuff. There's stuff on this that I haven't even touched on. Andy provides an LCARS output, so instead of having the interaction like this, it would have the next generation LCARS graphics, and you would press a button on the LCARS and create an effect. You'd have an effect occur on the model. It's crazy what this thing can do, and I can't even demonstrate any of that. So please, if you've got any kind of projects that you've wanted to do, but the lighting system has always been sort of, out of your reach, or you don't know even how to tackle it, this system will do it really easily and really quickly for you. And you need no programming. You've seen how I've stumbled my way through this. Again, I'm not good at this sort of thing, but even I can make this system work. So one last thing to mention is, like I said at the start, you can't just yank the power from this thing without asking for trouble. It is a computer system, so you've got the options buttons up here. You can back up and restore your configuration, so when you've built a really pretty complicated system, you can save that system information and then upload it to a new computer, or a new controller module. If you get a faulty module, you can back up and replace the module without having to recreate the program from scratch. You can reboot the system, shut it down. There's all kinds of stuff. You can update the firmware. Like I said a minute ago, Andy's updated the firmware. He does it periodically, adds new features, adds new functionality. This is an older version. I need to update it. But yeah, so when you come in to shut down, you just ask it to shut down, read the warning sign, wait at least 30 seconds after the shutdown procedure is done before you kill the power. That just gives the system enough time to properly shut down. So just, yes, shut it down. The lights will go off. If you've got this in sort of visibility, you can see the LEDs blinking in there. Wait for those to disappear, and then you can turn the power off. So there we go. I hope this makes sense. I really do. I'm going to see if I can make sense of this in the edit. If not, soz, Andy, I did my best. I'm not the best person to be demonstrating this thing, but I've tried to do my best. But like I keep saying, I'm bad at this, and if I can get the controller doing what I need it to do, definitely anybody can. So that's about it. So with all of that said, I'm going to start getting some epoxy mixed up. I'm going to glue this lid down and start making inroads into planning the paint job on this thing, because I really want to get this finished. It's like I keep saying, it's been very long in the tooth, and it's time for it to go to Terry where it belongs. So anyway, thanks for watching. Thanks for putting up with this. If you stuck with this till the end, good on you. You're a better man than me. Probably I might have tapped out before now. But I'll see you in the next one. Hopefully I won't be in my 50s by then, but you never know. I'll see you later.